Hey everyone, my name is Issa, and I want to talk about how computers count and, the binary, hexadecimal, all that kind of stuff. That's just going to be a quick video here. So, um, as you know, we count in base 10 because we have 10 fingers, 10 digits. So, really, when we count, we're really counting from 0 all the way till 9. So, there's 10 numbers, including 0 and 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. But a computer, they count in two digits, 0 and 1. So this is, on and off, on, off. And that's kind of just different. Now we could count in base 5, and really all that counting in different bases means that the maximum number you get to is that number. So for base 10, we count from 0 to 9, and once we hit 9, 9 is the last number that we actually have. And the next number, number 10, namely, is actually a combination of two numbers. So it's a combination of 0 and 1. So these two numbers make up 10. So now we have 1, and then so the tens digit, and then, from 0 to 9 here. So if it was like 12, it would be, a 1 and then a 2 together. There is no number 12, like its own entity. That doesn't exist. So if you had base 5, it would be from 0 to 5. So that means when you hit 4, there wouldn't be a 5. You would add another digit, and then this would be 0 to 4, and so on. The best way to think about it is when you have the number 99, one more becomes 100. It doesn't become. There's no number 100. Like it's a combination. You have to add another digit because that's the limit of two digits. And same thing with this. So 44 would be the limit of, of two digits for base 5. For computers, there's only two numbers. So we only have 0 and 1, on and then off. So when we work with binary code, the reason why computers work with binary is because it's electricity at the very fundamentals. And I recommend this video by Crash Course Computer Science. The first couple episodes, they talk about like logic gates and how electricity stores a bit. And so that's what these are. These are bits. Zero, so they're on or off. Electricity is flowing or it's not flowing. So when we work with binary, what's actually happening is it's going by powers of 2. So if we have the number 1101, well, how do we convert this? How do we interpret this as humans? Computer will see this and they got it. They understand. So something that I don't feel like is taught well enough in schools is that there's actually a trick to learning to doing this. They're all powers of 10 or powers of 2, sorry. So what you can do is you can think about, well, 2 to the 1 is 1, or 2 to the 0, sorry, we start at 0. So what we can do is we can break this up into a little box. And I'm gonna split it. So we'll use 1101. So this place is the first index. It's the 2 to the 0. Right here is 2 to the 1. Here is 2 to the 2, and then here is 2 to the 3. And this is kind of my strategy for converting between binary and decimal numbers. So we have a 1 here. So this 1, because 2 to the 0 is 1, that means this is the 1. This is 0, so 2 to the 1 is 2, but we don't have a 2, so we don't have this at all. 2 to the 2 is 4. 2 to the 3 is 8. So we have 8, we have a 4, and we have a 1. So 8 plus 4 plus 0 plus 1. Well, that's what, 12? 5. Oh god. 13. What am I saying? 13. Oh my god. So 13 is our number. This is 13 in decimal. And if you want to work backwards, let's say we have the number I don't want to do 20. That's a little. Let's do 20. Let's do 25. So what I do is, and this is probably too big, so let me make it longer versus bigger. So you would go find a power of 2. So I like to just write it out as numbers. So it's going to be 1, it's going to be 2, this is going to be 4, 8, 16, 32. So we already know that we don't want a 32 or beyond, because 32 is bigger than our number, which is 25. That doesn't look like a 25. 25. So there's definitely going to be a 16. What is 8 plus 16? Well, 9 plus 5 is 4, carry the 1, that's 24. And then we can just add a 1. Now, I'm probably going to double check this because I don't feel very confident in my math. But I think I did that right. 16 plus 8 plus 1. Yep, 25. Okay, this really doesn't. Yeah, there you go. So, and that's kind of the quick and easy way of converting between binary and decimal numbers. And this is how computers fundamentally work. So when you work, in assembly and stuff like that, you'll be working with these as bits, each of these numbers as individual bits, versus as like fancy constructs like in C++. Anyways, I hope this was helpful. If you have any more questions, leave a comment, join the Discord, link in the description. We got you. I'll see you next time.